Hi everyone. Today we're going to study direct proportion. Let us see this problem. If the cost of 1 kg of sugar is 18 rupees, then what would be the cost of 3 kg of sugar? The answer here is 54 rupees. In this problem, we see two variables. The first variable is the weight of sugar. We can refer that to be the variable x. And the cost of sugar can be the variable y. Two quantities x and y are said to be in direct proportion if they increase or decrease together in such a manner that the ratio of their corresponding values remains constant. So we can show like this: x over y equals k. K here is a positive number and a constant of proportionality. Then x and y are said to vary directly. In such a case, if y sub 1, y sub 2 are the values of y corresponding to the values x sub 1, x sub 2 of x respectively, then x sub 1 over y sub 1 equals x sub 2 over y sub 2. Here we have two formulas for direct proportion. Let us see this example 1. An electric pole 14 meters high casts a shadow of 10 meters. Find the height of a tree that casts a shadow of 15 meters under similar conditions. We let here x to be the height of the tree. Putting this on a table, we have like this. For this column, this is the data about electric pole, 14 meters in height with 10 meters as the length of the shadow. And for the tree, the height is x and the length of the shadow is 15 meters. We can see here that this is a direct proportion. Using our formula, x sub 1 over y sub 1 equals x sub 2 over y sub 2. Let us substitute the corresponding values. So it becomes x over 15 equals 14 over 10. Let us now solve for x. We do cross multiplication. This 15 to be multiplied on the right side to end it looks like this. X equals 14 over 10 times 15. We multiply 15 by 14, so we have 210 divided by 10. So we have x value equals 21 meters. This is the height of the tree. For direct proportion, we see that the general formula is x sub 1 over y sub 1 equals x sub 2 over y sub 2. However, alternately, we can use x sub 1 over x sub 2 equals y sub 1 over y sub 2. Also, direct variation is another term for direct proportion. Example 2. If the weight of 12 sheets of thick paper is 40 grams, how many sheets of the same paper would weigh 2.5 kilograms? We let x to be the number of sheets to weigh 2.5 kg. Putting this on table, for the number of sheets, we have 12 corresponding to 40 grams. For the next column, we have here x for the number of sheets corresponding to 2,500 grams. This is the value for the 2.5 kg. And we see that this is again an example problem for direct proportion. So we use our formula. Let us substitute the corresponding values. We have now x over 2,500 equals 12 over 40. Let us solve for x. We cross multiply this 2,500 to the right. We multiply now this 2,500 to 12. So we have 30,000 divided by 40. Finally, x equals 750 sheets of paper. This is the answer. We can note the answer here. Let us show an alternative formula or alternate solution. Remember that this is our first formula for direct proportion. X over y equals k. In this case, we're going to solve for the value of k. We substitute the values for x and y, which is the given. So we have 12 over 40 equals k. When we simplify this fraction, we will get the value of k as 3 over 10. So we have this k value. Now look at our formula here. Note that we can show that x is equal to k times y. Using this modified formula, we will now substitute the value of k and the value of y respectively to get the value of x. So x is equal to k, that is 3 over 10, times y, that is 2,500. Notice that this 2,500 and the denominator 10, we can cancel out. So it becomes 3 now multiplied by 250. So x is equal to 750 sheets, which is the same value that we derived from the first solution. Example 3. A train is moving at a uniform speed of 75 kilometers per hour. Here we have two questions. Let's begin with the first question. How far will it travel in 20 minutes? Remember that 1 hour is equal to 60 minutes. Let us conform this hour by 20 minutes and we write on a table. So we have like this. The distance is 75 per 1 hour or 60 minutes. For the first problem, we write here the x for the distance for 20 minutes. Let us now use our formula. Then we substitute the values. X over 20 equals 75 over 60. Let us solve for x. We cross multiply 20 on the right side. And we see here that we can cancel this 20 by 60. So, we have 75 over 3. And the quotient is 25. This is the value of x, which is in kilometers. So the value of x here we note as 25. Let us now solve for the second question. Find the time required to cover a distance of 250 kilometers. On this table, let us put another column and it becomes like this. We write here 250 and down here is the y corresponding to the time. Using our formula, we substitute the corresponding values and it appears to be like this. 250 over y equals 75 over 60. Let us now solve for y. We cross multiply, so we have 250 times 60 equals 75 times y. When we isolate y, we divide this equation by 75. And this 75 comes as denominator on the left side. Let us now simplify the product. 250 times 60, that will be 15,000 divided by 75. and the value of y is 200 minutes. Or we can write 3 hours and 20 minutes. These are now the final answers. Hi everyone, today we're going to study inverse proportion. Two quantities are said to be inversely proportional, such that if one quantity increases, the other quantity decreases, and vice versa. It means that the two quantities behave opposite in nature. We have here two examples. Number one, as the number of workers increases, the time taken to finish the job decreases. Example 2, increase the speed and the time taken to cover a given distance decreases. Inverse variation is another term for inverse proportion. Numerically, two quantities x and y are said to vary in inverse proportion if there exists a relation of the type x times y equals k between them, and the k here is a constant. In such a case, if y sub 1, y sub 2 are the values of y corresponding to the values x sub 1, x sub 2 of x respectively, then x sub 1 times y sub 1 equals x sub 2 times y sub 2. The left and the right sides are all equal to k, and that is the constant of proportionality. These are the formulas. Example 1. 6 pipes are required to fill a tank in 1 hour 20 minutes. How long will it take if only 5 pipes of the same type are used? We let x to be the desired time to fill the tank using 5 pipes. Let us put this in table. So, for the given, there are 6 pipes that can fill the tank in 1 hour 20 minutes. We convert this into minutes alone, so we write here 80 minutes. Our question now is, if we have 5 pipes, how long will it take? So we write here the x. Note that the lesser the number of pipes, more will be the time required by it to fill the tank. So, this is a case of inverse proportion. A while ago, we have the formula x sub 1 times y sub 1 equals x sub 2 times y sub 2. Let us substitute the corresponding values. So that means we have 6 times 80, that is the given, is equal to 5 times x. Let us now solve for x. We divide this equation by 5, and we will see that this 5 will come as denominator on the left side. Then we multiply 6 by 80, that will be 480, divided by 5, that will be the value of x. And x equals 96. And this 96 is minutes. So it requires 96 minutes for the 5 pipes to fill the tank. Example 2. There are 100 students in a hostel. Food provision for them is for 20 days. How long will these provisions last if 25 more students join the group. We let y equals the number of days for 125. That is, this original 100 students plus 25 extra. So total is 125 to consume food provision. Let us put this in table. On the given, we have 100 students consuming the food in 20 days. Now, on the next column, there are 125 students, and we put here the y. Note that the more number of students, the sooner would the provisions be exhausted. Therefore, this is a case of inverse proportion. Let us show our formula. Then we substitute the values. So we have 100 times 20 equals 125 times y. Let us solve for y. We divide this equation by 125. And this 125 will come as denominator on the left side. In the numerator is 100 times 20. That is 2000 divided by 125. And the value of y is 16, and this is in days. So it takes 16 days for 125 students to consume the food provision. Example 3. If 15 workers can build a wall in 48 hours, how many workers will be required to do the same work in 30 hours? We let y equals the number of workers to build a wall for 30 hours. In this column are the given 48 hours for 15 workers. On the next column, this is the required value. There are 30 hours and we want the value of y. Note that the more number of workers, the faster it is to build the wall. Therefore, this is a case of inverse proportion. Then we have our formula. We substitute the values. So 48 times 15 equals 30 times y. Let us solve for y. We divide this equation by 30. This 30 will come down as denominator on the left side. We multiply 48 by 15, that is 720, divide by 30. And the quotient is the value of y, that is 24. 24 workers are required to finish the wall for 30 hours.